So the score on a college entrance exams has an approximate normal distribution with a mean of 52 and a standard deviation of 11. All right, I'm going to draw our normal curve. I'm going to mark our values, and then I'll be comparing it to this breakdown we have above for every single problem that we do here. Right, so this was actually the same as our example from the previous page if you just want to look back to get the values, or we can redo them, practice. 52 is our mean, right? Our normal distribution with a mean of 52 and a standard deviation of 11. 52 is the mean. We have 1, 2, 3 on each side. 1, 2, 3 on each side. So we're adding 11 to the right. That's 63, 74, and 85. We're subtracting 11 on the left. That's 41, 30, and 19. All right, I'm going to copy this so that on each problem I can just paste it and redraw onto it. Okay, for the first one, we are looking for the probability. Remember to practice this every single time you do an example. Write the statement, write the question mathematically. The probability that a randomly selected student scores between 52 and 63. All right, let's also sketch it on our picture. 52, that is my mean. And I know my picture is not perfect, but that's meant to be the center. Here, let me try to fix the curve. That's meant to be the center. So that should be the highest point on my curve. And then we should go down from there. So maybe a little better. All right, so 52 to 63. This is the area that would correspond to that probability. If I look at my breakdown, that's not the 68%, right? 68 was one standard deviation on each side. It's only half of that. It's just this right-hand piece here, this one little section, all right? And that corresponds to 0.34, half of that 68%, or 34%, which again, when we write our answers for probabilities, we like to write them as the decimal value. That's how any calculator will give you that value. All right, let's look at another one. The probability that a randomly selected student would have scored between 41 and 74. All right, let's write the statement. Probability of randomly selected students scoring between 41 and 74. All right, let's shade it. 41. Okay, that's one standard deviation. Remember, this is my mean. That's my center. 1 to the left to 2 to the right. So this is not going to be an even 68, 95, or 99.7. We're looking at something not symmetrical here. All right. This was 68%, but we've added an extra little section to that. Okay, if I just take it slice by slice, we're going one standard deviation to the left to 2 to the right. So that's this slice, and this slice as well. We have to add all three of those together. So 0.34 plus 0.34 plus 0.135. Again, I'm kind of drawing each of them, but it's this section, and this section. If I'm looking at each chunk of my empirical rule to add each of those probabilities together. All right, so overall we have 0.815. All right, let's look at another one. I challenge you, now that I've shown you two, pause, see if you can complete the others, and then play or skip through to see if we got the same thing, okay? You should be challenging yourself, seeing if you can do these two. All right, we want the probability that a student scores between 52 and 85. I'm writing my statement mathematically. I'm drawing my picture. All right, 3 standard deviations on each side. I'm shading the corresponding region. So we're starting at that mean. Remember, 52 was the center. And we're going all the way to 85, 3 standard deviations to the right. So that's that first, second, and third on the right. If I go up and look, it's these 3 pieces here, right? So that's 0.34, 0.135, and 0.0235. Oops, 0.235. If I add all 3 of those together, I should get 0.4985. That's the probability that a randomly selected student scores between 52 and 85. All right, let's try another one. What is the probability that a randomly selected student scores between 19 and 63? All right, 19 and 63. So we're adding 1, 2, 3, 4 sections together for this one. All right, we are looking at 19. That's 3 standard deviations to the left to 1 to the right. 1, 2, 3 to 1 to the right. So that's this guy and that guy. All right, 3 to the left all the way to 1 to the right. So 0.0235 plus 0.135 plus 0.34 plus 0.34. If I add all of those together, I get 0.8385. All right, and on this one, it says, what's the probability that a randomly selected student would have scored between 0 and 52? Now note that 0 is the smallest score someone possibly could have gotten. So let me actually also rewrite this with a different question, okay? 0 to 52. I also could have asked you this, okay? Because that is, if I'm looking at my picture, we're going from 0 to 52. That's everything to the left. 0 is not on my number line because it's the smallest score I possibly could have gotten. You can't get a negative score on an exam, right? So it's essentially anything to the left, including this little tail piece that we haven't really used yet, all right? Remember that tail piece did have a probability though. It was very small, but it does have a probability. It is possible to get something less than 19. All right, I also could have asked, what's the probability that a student scored less than 52? And this would have been the same picture. We marked 52 and we shaded everything to the left. If I asked for a probability where we scored more than 63, we could mark 63 and we could shade everything to the right. And we could calculate that because we would just be including that little tail for anything outside of that extra range. All right, so although this is not, don't get confused, this is not what's written here. This is the probability they scored less than 52. But the calculation is the exact same because we are looking at everything less than 52. So I kind of wanted to add that in there just to give you like a little extra piece and a different situation. It doesn't always have to be between. You can do completely less than or completely greater than. You just have to make sure you include that little tail at the very, very end because there is a little bit of probability there. All right, 0 to 52 does include that tail because it is all of our possibilities on the smaller side. Again, it's the same thing as saying less than 52 because it's including everything down there. Okay, so we are adding together that little tail, right? We got to include this guy down here, as well as these three pieces there. So that little tiny tail, again, it's very, very small, 0.15%. But that 0.15% we write as 0.0015. It is a probability. That's that little tail at the very end. And then we have the 0.0235. We have the 0.135. And we have the 0.34. All right, little tiny tail and those three chunks there. If I add all of these together, some of you may have noticed or may have guessed it. This is 0.5. That's our median. 52 is our mean as well as our median because this is a perfectly symmetrical shape. The bell curve is a perfectly symmetrical display of data where your mean and median are the same exact value. So that's the 50th percentile. That's 50% of our data lies to the left. 50% of our data lies to the right. All right, but if we were to ask to be calculating, till here, it would be the same process. We would just add this extra piece. Okay, hopefully that helped. Hopefully that made sense. If you have questions about this, I know this was a little longer one, but it's very, very important for the places like our exam where we have to do by hand calculations. All right, so make sure you're practicing with this. I'll put extra questions on the review to make sure you get, a plethora of examples, but this is a good place to start, look at this page from scratch and try to redo every problem on your own without looking at your notes.